Hi everyone, Sean Morris here, CTO at Nasstar. Nasstar is a mid-market systems integrator, and last year we made the strategic decision to pivot our hosting and managed services business to public cloud and are investing heavily in growing our capability in the new exciting world of AI. What follows is a demo of a customer use case that shows off some of our capabilities in the AI and data space. The customer in question is a public sector transport organization. They received documents from the public which were processed for the purposes of registering for a recently deployed toll system. Increases in demand for this service was going to require 300 additional heads to process these registration, and our customer wanted to automate this manual document processing function with AI. Many organizations handle large volumes of documents, whether processing mortgage or employment applications or handling legal paperwork. The need for accurate and efficient data extraction is critical. Traditionally, this process has been manual, requiring significant human effort, which can lead to mistakes or overlooked errors. To address these challenges, we have developed an advanced AI solution that automates the extraction, processing, and verification of data from different document formats and structures. Our solution has three main features. The first one is data validation, where we cross-verify the extracted data from the document with the inputs given by the user during registration. The second feature is the quality assessment, where we evaluate the quality of the document in terms of contrast or blurriness to ensure an accurate extraction. And the third feature is fraud detection, where we verify the authenticity of the document and detect any modification or fraudulent alterations. For our solution, we are using the pre-trained layout LM model that incorporates the special layout of documents to recognize text, tables, images, and other elements from a document. These capabilities are particularly beneficial for processing documents with complex formatting. Once the document content has been extracted, we use a large language model from Azure OpenAI. Specifically in this case, we are using a GPT model, which is highly effective in extracting information from text. For this demo, we'll extract the name from the applicant, the address and postcode, and the date of the issue of the document. We'll also ask our AI model to classify the document based on its content. This example is a council tax statement, which has a complex format. When we click Analyze, we can see the different steps we go through. We connect to Document Intelligence, we extract the content, and then we connect to Azure OpenAI. We extract the entities that we need, we run our confirmation steps, and our task is complete. As we can see, this document contains multiple addresses. The first one corresponds to the City of Edinburgh Council, and then we have the applicant's details here on the top left, but we also have the property details on the top right, and we can see the issue date of the document is the 12th of March 2024. This document, however, also contains multiple dates corresponding to the tax financial year and the period for which the council tax statement is valid. When we see the output of our AI engine, we can see that the document has been classified correctly as a council tax bill, and all the details of the applicant are correct, and the date of the document is the 12th of March 2024. We'll use a different document now to demonstrate the verification steps. Here is where we validate that the information extracted from the document actually corresponds to the input data provided by the applicant. So in this case, we have a different matching score. Here we can see the address that the match is only 96%. This is because the address can be written in different ways. But we will provide an overall matching score. In this case, it's 98%. So we can set a threshold to the matching score, for example, 80%. And if this occurs, we can raise an error or reject for a human to validate the application process. Using another document to demonstrate the fraud check. For this, we are simulating fraud. We are using a modified document where we have edited the original dates from 2023 to 2024. So we implemented 3 checks to verify the authenticity of the document. First one is we look for anomalies in the metadata, like the creation or modification date. We also look for software overwrites or deleted metadata. We also look for signs of editing tools, document history, and so on. The second check is what we call X-ray analysis to detect hidden text. So this technique is particularly good for uncovering modifications where the new text or images have been placed on top of the original text. The final check is an error level analysis, and it is a forensic technique used to detect inconsistencies in images, which can indeed indicate a potential manipulation. So the idea is that all the elements that are in the original, from the original image, are going to be compressed at the same rate, while everything that has been added or any additions to the document are going to have a different compression rate. And if this is where we can see if there's any fraud or whether the document's been modified or not. If we look at the results of the uploaded file, we can see a warning in the metadata area because it hasn't found important keys like creation date or creation software. Now, although the error level analysis has passed, in the X-ray section it has detected that there is hidden text. If we look, we see the original text was 2023, and on top of this is 2024. We can now look at another document to show how the error level analysis works. So for this, we've used a utility bill where the last 3 characters of the postcode have been modified. If we go to the visual evidence, we provide different heat maps to see the different compression levels. If you look at the last 2 images here at the bottom, we can see the different compression rates. So like I said before, all the elements that are in the original from the image are going to compress at the same rate, while everything that has been added or edited in the document are going to compress at a different rate. So here in this image, we can see the user details. The oldest area of the user details, the name, address, and the first 3 characters of the postcode compress at the same rate, while the last 3 characters of the postcode have a different compression rate. This is very visible in this heat map when we analyze the blurriness, which looks at any change in font. We can see that the last 3 characters of the postcode are more bright than the rest of the document. We're using a final document to show a vehicle registration and that this file has been edited using Photoshop, and this is going to be detected by our metadata check. So when we expand and see the reason why it has failed, it tells us that it has been edited using Adobe Photoshop. When we go to the visual evidence, we have these maps. And the addition in this document is where the user details are and where the vehicle reference number is located. So we can see that we have a very bright area in the document, which shows the area where the edits have happened. Also here in this case, the noise is inconsistent, especially in this area where the reference number is located. So the goal is that with all these techniques, we can provide guidance whether or not the document has been edited. Well, I hope you found that demo interesting. It shows off a small example of an AI design win and the type of work we are doing leveraging the tools in the Microsoft AI ecosystem. If you want to know more or hear about other examples of the AI design work we are doing, then please connect with your Nasstar co-seller directly or reach out to our Sales and Marketing Director, Wayne Crocker, who can make an introduction. Many thanks for your time.